So now that you've learned how to find the vertex by completing the square, which is the best way to do it if you understand it, there is actually a shortcut. And I would disagree with it being a shortcut. I actually prefer to complete the square than I do the vertex formula. But there is what the textbook calls a shortcut to finding the vertex, which is an equation that was actually derived from completing the square. And what it is that you can find the x value of the vertex by plugging in coefficients from your equation into here. So your equation in standard form is ax squared plus bx plus c. A is the coefficient on your x squared term, b is your coefficient on x, and c is your constant. So to find the x value of the vertex, you do negative b divided by 2 over a. And then to find the y value of the vertex, you just plug this in for x into your original equation and then solve for y. So not sure if you're interested in this at all, but I also think it's good to prove to you that this is true. So this is the whole process of completing the square to then come up with this formula. So what they've done is they've kept the a, b, c, and then they've just rearranged the formula to complete the square. So they divided the coefficient off the x squared and the x terms. You end up with a times x squared plus b over a x. Then they made that into a perfect square trinomial by taking half the middle term and then squaring it. So half of b over a is b over 2a, squared is b squared over 4a squared. They added it and they subtracted it. You'll notice they do things on the left-hand side of the equation. So instead of keeping it as a one-line expression, they've made it an equation and they just put all the constants on the left, but that's just personal choice. And they kept going, they factored it, and then in the end, they end up with this. So in the end, you've got a times x minus negative b over 2a. So this is going to be the x value of the vertex. And then to find the y value, you plug it into the original equation. Now, this derivation that I found, they actually went further and found an equation for the y value, which I love personally, but our textbook doesn't do it. So technically, to find the x value of the vertex, you plug in negative b over 2a, and then to find the y value, you plug this into the equation. If you're watching this video and you want to write down this equation and use it to find the y value, you go ahead, okay? But I'm going to do it the way the textbook did it. So what we're going to do is we're going to find the vertex using this formula. Now I've chosen an equation here that is purposely hard. I've chosen one that I might not necessarily want to complete the square with. And that's kind of the real purpose for me with the vertex equation, is that if it's an equation that I don't want to complete the square, I'll use the vertex formula. So for example, if you look at this one, if I was to complete the square, I would greatest common factor out that 2, and I'd be left with x squared minus 5 halves x plus 1. And the only reason people don't necessarily like to complete the square with this is that you have to take half of that middle term and then square it. So it would be negative 5 over 4 squared, which is 25 over 16. And you'd add 25 over 16, and you'd subtract 25 over 16. And then you would create perfect square. So you'd have x squared minus 5 halves x plus 25 over 16. And then you would take this guy out and do 2 times negative 25 over 16 plus 1. So that it would end up as 2 times x, take half the middle term, so 5/4 squared. And then you'd have this on the end. So you'd have negative 50 over 60. Oh, sorry, don't do that. Simplify. Go, this is a 1, this is an 8. So you'd have negative 25 over 8 plus 8 over 8. And you'd find that your equation would look like this. So minus 17 over 8. So using completing the square, I can find the vertex. But there were some fractions, maybe some tricky stuff that you're like, ugh, I don't like that. So instead, let's look at what the equation, the vertex equation does. So to find the x value of the vertex, you're doing negative b over 2a. So we're going to plug in negative 5. So you could just put in plus 5. It's always the opposite sign on b, over 2 times the a term. And that gives me 5/4. So same thing here. This gave me a vertex of 5/4 and negative 17/8. This gave me an x value of the vertex of 5/4. Now to find the y value, I'll be official and call it a function. You just plug 5/4 into your function. So you'd have 2 times 5/4 squared minus 5 times 5/4 plus 1. Now, if you know how to use a calculator, if you're savvy, you can totally just plug this into a calculator. I'm going to do it the long way because I feel like it's good for me. So I'm going to square 5/4. I'm going to get minus 25/4 plus 1. I'm going to simplify to an 8. So I've got 25/8 minus 50/8 plus 8/8. So I have that common denominator of 8, and then on the numerator I've got 25 minus 50 plus 8. And hopefully these match. I get negative 17/8. So my vertex is 5/4 and negative 17/8. Now maybe some of you are like, fractions. If it's a beautiful decimal like this one, if you want to put in 1.25, you feel free to put in 1.25. Your vertex would be 1.25 and 17 divided by 8, negative 2.125. If you want to get that as an answer, there's nothing wrong with getting these nice decimals as answers. Feel free. If that makes it easier for you to find the vertex, I mean, if I was graphing, I would rather the decimal version anyway. So on the extra worksheet that I made, I put the fraction answers and the decimal answers because I don't care which form you give it to me in. And in fact, I don't really care if you do use the vertex formula. You have to know how to complete the square. The vertex formula is additional. It's if you want to do something a bit more. So let's look at this last one. So again, if I ask you to find the vertex and graph and I don't specify, you can find the vertex using the formula or completing the square. Let's practice the formula. So the formula is negative b over 2a. So it'd be negative 4 over 2 times negative 2. So the x value of the vertex is negative 4 divided by negative 4, which is positive 1. Then to find the y value, you're going to plug in 1 for x. So you get negative 2 times 1 plus 4 times 1 plus 5, and you get negative 2 plus 4 plus 5, which is going to give you 7. So my vertex is going to be 1, 7. If I had done this by completing the square, I would have factored that negative 2 out of the first two terms. So x squared minus 2x plus 5. Half the middle term is 1 squared is 1. I want to keep the perfect square, so x squared minus 2x plus 1. I'm going to take that negative 1 out by multiplying it by that negative 2, and then I'm going to add 5. I end up with negative 2 times x minus 1 all squared plus 7. So no matter which way I did it, I got this vertex of 1, 7. And sometimes it's nice to be able to do both to make sure you did it right. But now the question is, how do I graph? If you look at the equation in this form, you can see that a value. You have an a value of negative 2. That means your graph's going to open down, and it's going to be narrower. If you did it this way to find the vertex, you just have to look back up here. This is always the a value. A is always the coefficient on the x squared term. So if I went to graph this, I would put my vertex at 1, 7. And then I'd open it down and stretch by 2. So instead of going over 1 and down 1, I'm going to go over 1 and down 2 on both sides. Instead of going over 2 and down 4, I'm going to go down 8. So I'm going to go to this 1. And then can I go over 3 and down 18? No. So I'm going to connect my dots. And then on this side, I forgot that symmetrical point, and I'm going to go down. So now you know how to graph an equation given to you in standard form. You have to find the vertex, either using the vertex formula or completing the square, and then you are still able to graph from section 8.5.